Hi, my name is Edwin Madera, and in this video, I will be introducing and explaining the process to design a prototype of a parallel-jaw nutcracker. First, let's understand the focus, objectives, and constraints of the design. To quickly introduce the nutcracker, I will say that it is an efficient tool specifically designed to crack open hard nutshells, resulting in a nutritious snack of the kernels inside. The focus here is to create a parallel jaw nutcracker capable of efficiently cracking tropical almonds. A design and engineering consideration and assumption is given in the size where, in this case, we will design the parallel jaw nutcracker with a maximum length of 20 centimeters and a maximum height of 12 centimeters, as well as an applied force of 60 newtons on the base link and handle links of the nutcracker. For my design, I applied the principles of materials and mechanics to ensure an efficient and enjoyable nutcracking experience. In this slide, I provided the prototype design down below. As you can see, the mechanism links and components included are the base link that provides stability and support, the handle link, which is positioned at the lever arm for applying external forces, the upper jaw link and the base link, which exert pressure on the nut, and the connecting links, which establish connections between the handle, the upper jaw, base, and the base jaw links. For the material selection, I chose a cold rolled stainless steel AISI 302, which was chosen due to its resistance to deformation. And I also chose the ASTM grade 345 hardened steel, which was selected for the jaws to provide a superior wear resistance and withstand concentrated stress during cracking. The size of the jaws were calibrated to accommodate for a typical tropical almond nut, as we ensure the efficient pressure to crack the nut without compromising the mechanism's structural integrity. Now, we will dig deeper and get into the engineering analysis of the design. Through the static force analysis, we use assumptions including an applied force of 6 newtons and a mechanical efficiency for cracking at 4, a link cross-sectional area of 10 millimeters squared, and a safety factor of 4. From the equilibrium, we were able to determine the allowable stress at 130 megapascals, the force from the nut at 240 newtons, and the maximum stress applied at 24 megapascals, which all means that our link design is actually safe because the allowable stress is much more than the maximum stress that is applied. The kinematics analysis of the design includes an evaluation to validate the synchronized movement of jaws and nutcracker's opening and closing range, assuming the tropical almond nut of 40 millimeters by 25 millimeters and a required minimum range of 85 millimeters calculated using the total jaw opening range equation, which includes a clearance of 10 millimeters. I determined that a jaw opening distance of the link should be about 42.5 millimeters, making the jaw opening range the minimum of 85 millimeters. To conclude our analysis, the energy analysis took place, which resulted in 5.1 joules, which was gotten by multiplying the force, 60 newtons, by the total jaw opening range of 85 millimeters. The key parameters of the nutcracker performance are seen in the mechanism's links, as at least 6 links are included that contribute to the stability, force transmissions, and motion coordination. Another key factor is the parallel motion of the jaws that proved for effective nut cracking. Now, choosing a high strength material is essential for durability and performance. In my design, I chose the cold rolled stainless steel for links and the ASTM grade 345 hardened steel for the jaws, which ensured resistance to deformations. The geometric features to pay really close attention to is to accommodate the tropical almond nut dimensions and ensure the effectiveness of nut cracking without excessive stress on the mechanisms. And overall, the performance of the nutcracker relies on the design, the material selection, and geometric features, in all making the nutcracker a practical solution for nut cracking. To conclude this video, once again, this video was on the process of the design of a parallel jaw nutcracker. My name is Madera. Thank you for watching.